difference of squares. When given two perfect squares, the difference between them is equivalent to the first plus the second times the first minus the second. So a squared minus b squared is equivalent to a plus b times a minus b. So simply, you just take the numbers or the variables without the square, add them once, then multiply them by the difference. So it's the sum times the difference of the bases. Okay, so we have x squared minus 4. We need to put in the form of a squared minus b squared. So x squared is already in the form of a squared. How can I make 4 into the form of b squared? What base to the power 2 is a 4? Of course, 2, because 2 times 2 is a 4. So x squared minus 2 squared. Now we have it in the form of a squared minus b squared. So find the sum of your bases. So these are my bases, right? Base, exponent, base, exponent. So my first base is x. My second base is the 2. So the sum of the bases times the difference of the bases. Let's look at some mental math. A simple multiplication problem such as 43 times 37. Of course, everyone wants to jump to the calculator, plug it in, hit enter, you'll get the answer, good job. Of course not. We need to use some little bit of mental math to see how does this rule apply to simple math. If you're at the store, you don't have your cell phone on you, you don't have any technology device can help you out, you can just do, if I have 43 items, each cost $37, you can do the math in your head. You ready? So, 43 is simply 40 plus 3 times 37 is simply 40 minus 3. Now, take a minute to look at it and see if you notice any relationship. So, you have the sum of two numbers times the difference of the same exact numbers. Does that remind you of something? Of course, the difference of square. So, you can just simply say, okay, that means that 40 squared, first base squared, minus the second base squared. Oh, that's a lot easier and simple. 40 squared is simply 1600 minus 9 equal to $1,591 if you're buying stuff. Let's look at some quick examples from your worksheet. Let's do number 1. You have 9x squared minus 1. Now, the rule again says a squared minus b squared is equal to a plus b times a minus b. The sum times the difference of the bases. Okay. Now, we have a small challenge here. 9x squared. the square belongs only to x. We need it to be in the form of a squared minus b squared. Now, 1 is an easy number. We all love the 1, right? Because 1 squared is just 1. So, now I got my b squared. Now, let's look at the a squared, which is my little bit of a challenge, but it's not a big deal. Which base to the power 2 equal 9? Which base to the power of 2 is a 9? 3. So, 3x all squared minus 1 squared. Now remember, if you don't remember the rule, please review your power rules. If you have 2 terms multiplied in parentheses to the power square, that means each of these terms has a square. Now, this is my A, this is my B. So simply, it's A plus B times A minus B. And you're done. Let's look at number 4. That's a way easy one. So you have p squared. Oh, now here's a small challenge. It's not a big deal. What base to the power 2 equals 36? 6. Because 6 squared is a 36. Okay? So you have p squared minus 6 squared. So sum of the bases times the difference of the bases. Look at number 7. (180m squared minus 5). We have 2 problems here. The 180 and the 5, they will not fit a perfect square. What base squared equals 180? None. Okay. What base squared equals 5? Also none. But here's a good relationship between the 180 and the 5. 5 is a factor of 180. 180 is divisible by 5. That means I can factor the 5. 180 divided by 5 is 36 m squared minus 1. Oh, that's awesome. Look at that. So we factor the 5. So the 5 can just be outside of the plan. You have 36m squared minus 1. Can I make this in the form of a squared minus b squared? Oh, absolutely. We already said that 1 is an easy number to play with. Now, what base squared is equal to 36? That's an easy one. 6. We also did it here before. So, we have 6m all squared minus 1 squared. Let's factor it out. You're going to have, don't forget your 5. You have the 5 times a, b times a squared. So we'll have the first base is 6m plus 1 times 6m minus 1. So again, we factor the 5. We got 36m squared minus 1. 1 is simply 1 squared. 36m squared is 6m all squared. Don't forget the 5. So now we have the form of a squared minus b squared. A is 6m, b is a 1. So 6m plus 1 times 6m minus 1. Two a squared minus 45. Again, we have the same problem. We do not have perfect square. No base to the power 2 equals 20. No base to the power 2 equals 45. If that's the situation, always think about factoring out. What is the greatest common factor between 20 and 45? Again, it's 5. So if I factor the 5, 20 divided by 5 is 4a squared minus 45 divided by 5 is 9. Okay. Now we need to make it in the form of a squared minus b squared. What base to the power 2 equals to 4? 2. So 2a all squared minus what base to the power 2 equals 9? 3. Again, do not forget about your 5. Good, I got my a's and I got my b's. So I still got my 5 times 2a minus 3 or plus 3 times 2a minus 3. Next, 3n squared minus 75. Again, no perfect square, no perfect square. 3 and 75 have a common factor of what? Of 3. So let's factor the 3. You have n squared minus 25. 75 divided by 3 is 25. Oh, that's an easy fix. What base to the power 2 is 25? 5. Okay. So, I got my A and I got my B. So, 3n squared minus 5 squared. Again, don't forget your 3. So it's n plus 5 times n minus 5. Now, please pause the video and try to work problem 14 on your own, and let's see if you guys are going to get the right answer. If that's your answer, then good job. If not, then it's okay. We can just work on it a little bit more and you'll ace it soon.